Now we have defined the derivability and continuity of functions. We take up some questions now. The values of a, b, c, for which the function fx equal to sine of a plus 1 times x plus sine x upon x when x is less than 0, c when x is equal to 0, square root of x plus bx square minus square root of x upon b x raised to power 3 by 2 when x is greater than 0 is continuous at x equal to 0. Or, so this function is going to be continuous, we have to find out a, b, c. The options are a is equal to 3 by 2, b is non-zero, c is 1 by 2. Second option, a is minus 3 by 2, b is non-zero, c is equal to 1 by 2. Option C, a is equal to minus 3 by 2, b is non-zero, c is equal to minus 1 by 2. D is none of these. For continuity at x equal to 0, we must have limit delta x tends to 0 f of 0 plus delta x equal to limit delta x tends to 0 f of 0 plus delta x equal to f of 0. Delta x is greater than 0. Now we take up left hand limit. That is limit delta x tends to 0 f of minus delta x. That is limit delta x tends to 0 sine of a plus 1 times minus delta x plus sine of minus delta x upon minus delta x, which can be written as sine of a plus 1 times delta x upon delta x plus sine of delta x upon delta x, knowing the fact that sine of minus theta is equal to minus sine theta. Now, operating on limits separately, we get limit delta x tends to 0. We multiply and divide by a plus 1 in the first expression, leading to a plus 1 times sine of a plus 1 times delta x upon a plus 1 times delta x plus sine of delta x upon delta x as delta x tends to 0. And the first limit becomes a plus 1 into 1, that is a plus 1. The second limit becomes 1. Therefore, the limit becomes a plus 2. This is left-hand limit. Now we switch over to find out the right-hand limit. Now right-hand limit is equal to limit delta x tends to 0 of f of delta x, which is limit delta x tends to 0 square root of delta x plus b times delta x whole square minus square root of delta x upon b times delta x raised to power 3 by 2. Rationalizing the square roots term, that is the numerator, we get limit delta x tends to 0 delta x plus b times delta x whole square minus delta x upon b times delta x raised to power 3 by 2 into square root of delta x plus b times delta x whole square plus square root of delta x, which simplifies to b times delta x upon square root of delta x, and pulling out square root of delta x common from the second expression in the denominator, we get square root of delta x into 1 plus b into square root of delta x plus 1. The limit becomes 1 upon 1 plus b, 1 plus 1, which is equal to 1 by 2 and b not equal to 0. Therefore, f0 is equal to c, left hand limit is equal to a plus 2, right hand limit is equal to 1 by 2. For continuity, all these three must be equal. That is, a plus 2 is equal to c is equal to 1 by 2, where b is not 0. Hence, a is equal to minus 3 by 2, b is not 0, and c is equal to 1 by 2, which shows option B is correct. Next question is, if a function fx satisfies the relation that fx plus f of y is equal to f of x plus y, for all xy belong to R, and fx is given to be continuous at x equal to a, then the options are: fx is not continuous at any other point except x equal to a. B, fx is continuous at x equal to 0 but not at any other point. C, fx is continuous at all points. D, none of these. Now given f of x plus y is equal to fx plus fy, also fx is continuous at x equal to a. Therefore, limit x tends to a, fx is equal to f of a. Now limit of delta x tends to 0, f of a plus delta x is equal to f of a. But f of a plus delta x is given to be equal to f of a plus f of delta x, using the fact that fx plus fy is equal to fx plus f of x plus y. So limit delta x tends to 0 of f of a plus f of delta x equal to f of a. This clearly shows the f of a plus limit delta x tends to 0, f of delta x is equal to f of a. This shows that limit delta x tends to 0, f of delta x is equal to 0. Now we proceed to show the continuity of the function at any other point. To consider the continuity at any other point, say alpha, limit delta x tends to 0 of f of alpha plus delta x, which becomes limit delta x tends to 0 f of alpha plus f of delta x, using the 1, that is the definition of the function, which is limit delta x tends to 0 of f of alpha plus limit delta x tends to 0 f of delta x, which is f of alpha plus 0, that is f of alpha. Thus, limit delta x tends to 0 of f of alpha plus delta x is equal to f of alpha. Thus, fx is continuous at any other point, arbitrary point alpha. Hence, it is continuous at all points. Option C is correct.